Why do the fastest jets in the world have such tiny wings? The physics is insane. Hey everyone, welcome back to the channel. Today, we're diving into an absolutely mind-blowing question about aviation. Have you ever been at an airport and noticed something weird? Passenger planes like the Boeing 747 or Airbus A380 have huge wings, right? But then you look at military jets, especially supersonic ones, and their wings are ridiculously small. Take the X-15, the fastest plane ever. It barely even looks like a plane. It's more like a rocket with tiny wings attached. The F-104 Starfighter's wings were so small, pilots joked it was a missile with a man in it. So, if planes need lift to fly, why do the fastest ones use these tiny, seemingly useless wings? The answer comes down to a battle between speed and drag. Let's get into it. First, let's quickly recap how planes actually fly. To get off the ground, a plane needs something called lift, and wings are what generate that lift. The physics equation basically says lift depends on two things: the plane's speed, velocity, and the wing's surface area. Simply put, if you want more lift, you've got two options: make the wings bigger or make the plane go faster. Gliders and regular passenger planes fly at subsonic speeds, slower than the speed of sound. Since they're not super fast, they need that large wing area to generate enough lift to stay airborne. The air flows over the wing, creating that upward force. But jet fighters are a whole different story. They fly at Mach 1, the speed of sound, Mach 2, twice the speed of sound, and beyond. At those speeds, the air isn't just air anymore. It's more like a thick, resistant wall. Ever stick your hand out the window of a moving car? At slow speeds, not much happens, but go faster and the wind pushes your hand back. That's drag. Now, imagine a jet going supersonic with massive wings. Those wings would slam into the air like hitting a brick wall, creating insane amounts of drag. This drag wouldn't just slow the plane down, it could literally rip the wings apart. So at high speeds, big wings become a liability. Then there are shockwaves. When a plane goes supersonic, it creates shockwaves in the air. Big wings would get hammered by these shockwaves, causing the plane to vibrate and become difficult to control. That's why engineers design wings to be as small, thin, and swept back as possible. Let's talk about the F-104 Starfighter. Back in the 1950s, the goal was to fly highest and fastest, so engineers made the wings incredibly thin and short. They were so sharp that ground crews had to put covers on them to prevent accidental cuts. These tiny wings allowed the F-104 to climb like a rocket and break speed records. But here's the catch. While tiny wings are great for speed, they're terrible for low-speed handling. Remember, lift needs either speed or surface area. With small wings, less area, the plane can suddenly lose lift when slowing down for landing. That's why jets with tiny wings have to land at ridiculously high speeds. They can't just glide in slowly or they'll drop like a rock. To solve this, planes like the F-14 Tomcat and Tornado used variable swing wings. During takeoff and landing, low speed, the wings would extend outwards, increasing the wing area and generating more lift. Then, for high-speed combat, the wings would sweep back, reducing drag. It's an ingenious piece of engineering. But modern planes like the F-22 and F-35 don't use swing wings anymore. Why? Because those mechanisms add weight and complexity. Instead, modern engineers design the entire fuselage, body of the plane to generate lift. Plus, they boost engine power to the max, making small wings less of a problem. In conclusion, nature always demands a trade-off. If you want to fly the fastest, you have to sacrifice stability and easy landings. The tiny wings on the fastest jets are a symbol of humanity's obsession with speed and the triumph of aerospace engineering. So, what do you think? Would you rather have big wings and a smooth ride or tiny wings and rocket-like speed? Let me know in the comments. And if you enjoyed this video, don't forget to like and share. Subscribe for more awesome content like this. See you in the next video. Bye!